Tell me when.
Go.
All right, Hunter, we're super bummed that you're still not here, so if you would, work on that, and we're sorry to hear you're still feeling bad, and just get well, get back here. All right, I was talking about our homework was OYOs 1.4 to 1.6, but we're just gonna put that on hold and do another example and some warm up and work up to those, and I'll give you a chance to work on, to fix those if they need fixing, so to speak. All right. So, before I dive into our warm-up, let's talk about the lab. So lab for a few seconds anyway. It's due tomorrow. It is a list of calculations and data followed by an explanation paragraph of what was done, and then a conclusions, few sentences, small paragraph, concluding, and if you're not sure what to conclude, your book will help you. That read page 15. I believe it was the page after the green explanation of the experiment. And then there was a list of principles used. Again, that can be just a list. It doesn't have to be full sentences. Any questions on the lab? What I expect it is due tomorrow morning at this time. All right. Sounds like you're all set going for that. Let's do a warm-up. So if you would find an area on the black desk which doesn't have a paper book or anything else, I'll have you, first of all, practice some slope concepts.
Thank you.
You're welcome. Find a spot on your desk so that I can see it, so it's not covered up by someone else's books. So. What I want you to do, and you'll need an eraser, these work pretty good. We're going to practice first of all some slope concepts, which you're bringing with me. I mentioned them quickly yesterday, but bringing with you to me, mostly from math class. So first of all, draw me a slope draw me a line that has slope 0. So if you were out skiing, it wouldn't be a very good place. It wouldn't be very fun. So you want slope 0. One line. So Alex, one line.
Oh, I was like drawing a graph. And I was
Okay, you can put it on there
okay.
then. That's fine. I get it.
Makes it a lot easier.
All right. So draw a line with slope 0. Brian, where's your line?
Oh, we're putting it on the desk?
Yes. Sorry, I didn't make that clear,
Are the
did I?
desks made for chocolate degrees though?
Pardon?
Are the desks made for
No.
chocolate degrees? No.
It's a science table, so you can pour like hydrochloric acid on it. It doesn't hurt
Yeah,
it,
it's
so.
just a
that's
chemistry.
cool.
It's a
That's
chemistry
good.
science
You
table.
can't
You
Just
can't
use
beat them up too much. So I figure a little chalk's not going to hurt, right? All right. Now leave that on there. So from that, I want you to draw another line, not from it, but around it, above it, even probably above would work the best, but somewhere. Draw a line that has a slight positive slope. So you should have started with a flat line in that you were no slope. So this is slope 0. Now you're going to go toward a slight slope. So this is a positive slope. Mark it with a plus sign. So a positive slope goes from the lower left to the upper right. All right. So now give me one that has a higher slope but still positive. It's slopier, I'll say. So if you're a good skier, you're glad. All right. Very good. So then one that is completely vertical. At that point, we say, do you think we recall from math class what kind of slope we assign to a vertical line? Pardon? Undefined. Thank you. All right. All right. Well trained you come. Well taught. So we have a slight positive, more positive. This is a higher slope, as you would tell if you were sitting there on a sled. This is a higher slope. So if this was slope 1/2, this could be slope 1 or 1.5, 2, so forth. And here we have a slope that is undefined.
A good skier does not go on an undefined slope.
Pardon?
A good skier does not go on an
No,
uneven slope.
no, good point. All right, now we're putting in some negative slopes. I want to do like the matching slopes over here. So we're going to have a negative slope that's very high in the negative direction, and then a more gentle slope in the negative direction, and then we're back to 0. So there's a little slope map that we have created. If I ask you to look on a graph and find a slope that is high, you're going to look for these kind of lines or these kind of lines, and it doesn't matter if they're positive or negative. These lines in here have high slopes. These lines, low slopes. All right, erase your slope map. That's your big slope review. Now I'd like you to draw, to the best of your ability, a circle. And on that circle, I would like you to put some dots. And on those dots, they can be, say, 4 dots non-symmetrically around the circle. So 4 dots on the rim of the circle that are not symmetrical. So put them at odd spacings around the circle. So I'm going to pick one here, one here, one here, and one here. All right, this is not yours. We're branching from slope review to tangent review. So now in geometry class, you learned that a tangent line touches the circle in one spot. So I would like you to create a tangent line, which is going to be as straight as you can draw, with at each of the 4 spots that you selected. So here's my tangent line, my tangent line, my tangent line, and my tangent line. As a teacher, I've been challenged, maybe even frustrated by the fact that when I define a tangent as a straight line that touches a circle in one spot, I do get some years this as my answer. I see that you are doing it like I did, but this seems to satisfy the definition. So here's this orange line here. It goes through the point and it touches a circle in one point. How could I explain better to someone that that is not a tangent line? What's the difference? This is touching it at one point. What would you say, Brandon?
Well, it's often going into the circle. The other
Right,
one
it
is just like on the
cannot-
outside touching.
Right,
one
it
point.
has to stay on the outside of the circle or the curve. So it can't penetrate inside of the circle. So probably when I made that definition, I didn't make that clear. So that's the kind of tangents I got. So, all right, now erase your circle. I could see them, thank you. And give yourself one hill. So I want a hill that's going up and down. And along the hill, I want you to pick 4 dots. Erase and give me a hill. 4 dots. Just random dots on the circle. I picked those. All right. All right, with the hill and the 4 dots, I want you to create a tangent line at each of those. All right, look at my 4 tangent lines and notice that some of them are underneath the curve and some are above the curve. For example, this one, it all depends the bend of the curve. So if the curve is bent like this, we call it concave downward, then the tangent lines, in order to touch the curve at one point, have to be above the line, most of the tangent line. And then here and here the same. But notice the bend starts going this way. Like this was a frown and now we're into the smilers down here. So the bend is different. So the tangent line will switch and be on below the line. It will still never go above the line if it starts below, or below the line if it starts above. So let me see your creations. All right. And if you had one here, what would it look like? Okay,
Pretty
good.
darn close to the hill, go up,
All right.
not actually touching it.
All right, so you had some above and some below. All right, this one kind of pierces.
Yeah, I didn't mean for it to like.
Okay,
like,
all right, just so you know.
This would be above
This
it.
one is a piercer. See, we can't do a tangent line like that. So can you draw a tangent line? This one's gonna have to be below because this is dipping down. So can you draw a straight line touching it below? Do you see the difference between that one and the one you had? Okay, all right. All right, this one like pierced as well. So it can't be above because this is like sloping this way. So you're gonna have to make it below and straight there. All right, and do you have any above and below?
I did.
This one's sort of below, right? Okay. All right, so that's your tangent line training. Be aware that they can't pierce this line. They just touch it, graze it in one spot, and the whole line stays either on one side or the other. So that's how you construct a tangent. When we were looking at tangents yesterday, they actually were serving us. So I think that's all I need for our table review. We'll put one more thing on. One more, just as you're doing a good job there. I want you to erase what you have and give me another hill. Pick one spot on the hill. So give me another hill and one spot on it. Okay, so I'm gonna pick this one. And so here's the smile where all my tangents are above. This is where it starts on the frowner. So I want you to create one tangent there. So mine is sort of below at that point. It's hard to get it, but it is. And now I want you to pretend like I'm asking you to find the slope at that point. So I want you to take that tangent and create a right triangle where the tangent is the hypotenuse of the triangle. So can you drop down from the top and go across and create a right triangle as if I was asking you to calculate the slope? So let me see your triangle. Okay, that's good. All right, that has to be a right triangle. You pick the one spot that you can't make a triangle for, and we'll, if you would save that, because that's my next discussion.
Okay.
So try one on the sides, because remember, we just discussed the straight line has no slope, so we're not gonna be able to create a, that's why you're having trouble there. All right, you've got a good triangle going. Good one. All right, check yours. Good one. Oh. All right. So if I had this on a piece of graph paper or on a scale drawing, you would find the slope by doing what? What would you do, Emily Keene, with this triangle to find slope?
You get the 2 points.
Like here and here?
Yep.
And then?
And then you do y2 minus y1 over.
Alright, so that's one way. What's another way? Which is really the same way, but slightly different bend to it. Can you think of something else? Zach, what else could I do? So she's taking the name of this point and calling it x1, y1, and this point and calling it x2, y2, and plugging it into the formula. What else, Zach, could we do? More geometric than algebraic. Hers was algebraic.
Get the rise over run.
Right, a rise over run. So in physics class, I do that because it's usually, I can look at this is the rise, this is the run, and I can go over here on some scale and read the numbers on the units. And then I can go over here, rise over run. Yeah.
We gotta stop.
Okay, just close it.